This is the Fairchild Republic A-10 Thunderbolt II, also known as the A-10 Warthog. America's ultimate tank killer and a guardian angel for ground troops. The plane can deliver devastating firepower, all while surviving tremendous punishment. But what makes this awkward-looking plane one of the most beloved and effective close air support aircraft ever built? We've modelled the A-10C in minute detail to explore this military marvel inside and out. With its distinctive twin-engine design and a powerful 30mm cannon that is bigger than a Volkswagen Beetle, the Warthog is unlike any other aircraft in the world. In this video, we'll be focusing on the modernised A-10C version that showcases the best of this aircraft's close air support technology. I'm David Webb, and this is Blue Paw Print. The Warthog's airframe is a masterpiece when it comes to survivability. The plane measures 53 feet 4 inches long and stands 14 feet 8 inches tall. It has a wingspan of 57 feet 6 inches and a wing area of 506 square feet. The A-10 weighs 24,959 pounds when empty, but it can take off at a maximum weight of 50,000 pounds, which means it can carry almost as much ordnance as it weighs. The A-10's design is about being cost-effective and tough on the battlefield. About 95% of the fuselage features stress and corrosion-resistant aluminum alloys with sections riveted together. The designers avoided composite materials and opted for flat plates for much of the aircraft's skin. These are interchangeable between the left and right sides. The fuselage features forward, center, and aft sections. The forward section is home to the giant GAU-8 cannon system, and the entire underside swings open for easy maintenance. The center section holds the main fuel tanks. The aft section contains the auxiliary power unit, which supplies electrical power and compressed air for starting engines and ground maintenance. The A-10's wings are perhaps its most distinctive feature and are designed specifically for low-speed, low-altitude missions. They use a 3-spar design, a straight center section, upward tilting or dihedral outer sections, and wingtips that droop down called Hohner wingtips, which reduce drag and improve airflow over the wings. The fuel tanks are built into the straight center sections in addition to the main tanks found in the fuselage. The outer sections of the wings tilt upwards at a 7-degree angle for improved stability during flight. They're constructed using strong yet lightweight honeycomb panels. There are similar structures all over the plane. The Hohner wingtips serve multiple critical functions. They work like winglets, cutting down on drag and helping the A-10 to stay in the air longer, which is essential for close air support. The droop design boosts the wingtips' efficiency, making the ailerons more responsive and improving the plane's maneuverability at low altitudes. This setup also provides STOL capabilities, or short takeoff and landing. Fully loaded, the A-10 can take off on a runway as short as 4,000 feet. The wings are positioned low, which allows for more weapon-carrying pylons without compromising low-level handling. The wings are straight with no sweep because the A-10 was built to be a subsonic aircraft focused on loitering in battle rather than moving at high speeds. The A-10's control surfaces are larger than those on most similar aircraft, and they're there to handle the tough demands of low-speed, low-altitude combat. The ailerons are a standout feature, stretching across nearly half the wingspan to provide exceptional control, even when flying slowly. These ailerons are split and also work as decelerons, opening up above and below the wing to act like air brakes during maneuvers or landing. Single-slotted Fowler-type flaps, an extension of the wing that runs along the rear, are located inboard of the ailerons. They're hydraulically operated and have 3 settings to improve airflow and give extra lift at lower speeds. On production models, these flaps are set to 20 degrees, which is half of what the original prototypes had. They're also interchangeable. The A-10 can still fly, even if one flap is completely destroyed. The A-10's flight controls use 2 independent hydraulic systems, plus a mechanical backup with cable routing designed for maximum combat survivability. This cable setup allows for backup control, even if the hydraulic power is lost, meaning pilots can still fly the aircraft home using manual mode. In an emergency, pitch and yaw control engage automatically, while roll control remains in the pilot's hands. The tail, or empennage, has twin vertical stabilizers. It allows the aircraft to stay in the air, even if one of the vertical stabilizers gets taken out by enemy fire. Both rudders and elevators are made from the same honeycomb composite as the outer sections of the wings, which makes them lightweight yet strong. The elevators also have trim tabs on the outer edges, and the whole tail assembly, again like the wings, is designed so that parts can be easily swapped between the left and right sides. The A-10 is powered by 2 General Electric TF34 GE100 turbofan engines, each producing 9,065 pounds of thrust. The engines are mounted high and behind the wings. The way the exhaust nozzles are angled up helps reduce jet blast on the ground and keeps the aircraft's heat signature lower, making it harder for heat-seeking missiles to lock on. By having the engines in separate nacelles, the design makes it less likely that a single hit could take out both engines at once. Each TF34 engine breaks down into 5 main parts, making maintenance easier. The single-stage fan has titanium blades that can be individually removed and replaced through access slots without needing to take the whole engine apart. The 14-stage axial compressor incorporates variable stator vanes in the first 5 stages. These vanes adjust their angle automatically to control airflow. The annular combustion chamber is made from tough nickel alloy parts for a longer lifespan, and the turbines provide reliable power, allowing the aircraft to go from idle to full throttle in just 10 seconds. All 4 main fuel tanks are placed near the center of gravity and are separate from the fuselage, so any projectiles have to get through the outer skin before hitting a fuel tank. The wing tanks can hold a total of 622 gallons, while the hull tanks can hold 1,022 gallons, bringing the total internal capacity to 1,644 gallons. The fuel transfer lines are designed to seal themselves if damaged, and check valves stop fuel from flowing into any compromised tanks. If all 4 main tanks ever get hit, 2 self-sealing sump tanks still have enough fuel for about 230 miles of emergency flight, which could help a damaged aircraft make it back to friendly territory. The A-10's primary weapon is the legendary GAU-8 Avenger, a 7-barrel, 30mm Gatling cannon that defines the aircraft's entire design philosophy. Weighing in at around 3,900 pounds when fully loaded, the GAU-8 makes up around 20% of the A-10's total weight, making it one of the largest cannons ever mounted on a plane. The whole airframe was literally designed around this weapon system, and it has been said, while other planes have guns, this gun has a plane. The rotating assembly contains the 7 barrels, each with its own chamber and bolt. In the middle is a stationary housing with a cam path. As they spin, the bolts engage with the path, which drives the functions of loading, chambering, firing, and extracting the casings in a single revolution. This allows the gun to achieve an incredible fire rate of 4,200 rounds per minute. But in the A-10C that we're depicting, the gun is slowed to 3,900 rounds per minute to extend the weapon's lifespan. The signature A-10 sound comes from the extremely rapid firing. The human ear can't separate each shot. Instead of distinct bangs, the shots blur together into a continuous flat, buzzing growl. With the muzzle velocity reaching more than 3,000 feet per second, the shots surpass the speed of sound, with soldiers on the ground saying, "If you hear the A-10, then you're not the target." The cannon is mounted slightly to port, but the firing occurs on the barrel dead in the center of the aircraft to prevent the gun's massive recoil from pulling it off target. And massive is not an exaggeration. At the maximum fire rate of 4,200 rounds per minute, the gun creates 19,000 pounds of recoil force. To put this in perspective, the A-10's two engines combined produce about 18,000 pounds of thrust at full power, so the cannon's force actually slows the aircraft down while firing. However, the average recoil when firing in bursts is about 10,000 pounds. To feed the weapon, the aircraft has an ammunition drum that can hold up to 1,200 rounds of 30mm ammunition, although it usually carries about 1,174 rounds for combat. A single round for the GAU-8A is huge, and is often compared to the size of a well-known energy drink can. However, the original can measures 2.09 by 5.28 inches, making a single 30mm round longer, slimmer, and vastly more damage inflicting. The weight of the ammunition is significant, and with the drum being placed so far forward, it means the balance of the aircraft can be severely affected as ammunition is spent. In an effort to mitigate this, the spent casings are sent back into the drum rather than tossed overboard, so they act as ballast. This has the added benefit that it prevents the massive amount of brass from finding its way to the engines. The typical ammunition setup is one high-explosive incendiary round for every 5 armor-piercing incendiary tracer rounds. The armor-piercing rounds are made from depleted uranium. This is uranium that is largely no longer radioactive, but it still has terrifying properties. When striking enemy armor, depleted uranium self-sharpens, unlike other metals that become blunt, allowing it to penetrate further into the armor. Upon striking a target, the uranium shrapnel ignites in contact with the air, which can set off enemy ammunition and other flammables inside the target, making them devastatingly effective against armored vehicles. Combat tests against captured Soviet tanks showed just how deadly the GAU-8 can be. In tests with T-62 main battle tanks, it took out 6 out of 10 targets, with 3 of them suffering catastrophic damage. Besides the cannon, the A-10C can carry up to 16,000 pounds of weapons on 11 hardpoints, including 8 under the wings and 3 under the fuselage. This impressive capacity lets the aircraft carry various bombs, including laser-guided and GPS-guided munitions, a mix of AGM-65 Maverick missiles, Hydra 70 rocket pods, and A-9 Sidewinder missiles for self-defense. It also carries laser-guided weaponry. The AN/AAS-35 Pave Penny Laser Receiver Pod was one of the first upgrades for the A-10 in 1978. It was mounted below the cockpit to detect laser reflections from ground designators, which let the A-10 drop laser-guided bombs whilst only receiving signals. More recently, the Pave Penny pods have been replaced by advanced targeting pods, like the AN/AAQ-28 Lightning product, produced by Northrop Grumman. This new system combines laser designation with range finding and multi-sensor capabilities, making it better at finding targets and hitting them accurately. On April 6, 2003, Lieutenant Colonel Raymond T. Strasburger showed the A-10C Thunderbolt II's unmatched close air support capabilities during a crucial engagement near Baghdad. Leading a flight of A-10s, Strasburger ran into some enemy armor that was attacking Task Force 269 near the Tigris River Bridge. Even though a sandstorm made visibility near the A-10's operational minimum of 1.5 miles, Strasburger kept pushing forward. Protected by the 1,200-pound titanium armor bathtub cockpit, Strasburger skillfully dodged intense anti-aircraft fire with a total disregard for his own safety. The 33-minute engagement highlighted how well the A-10 can maneuver at low altitudes. The A-10C's ability to fly under 1,000-foot ceilings proved decisive. Strasbourg was able to make precise attack runs at low speeds to accurately identify and hit ground targets. The aircraft's ability to handle up to 7.3 Gs in combat allowed for tight turns, letting him repeatedly attack from the same heading while keeping friendly forces safe. By taking out 3 T-72 tanks and 6 armoured personnel carriers, the A-10's GAU-8 Avenger proved how effective it can be, and the A-10's fuel-efficient engines allowed Strasburger and his wingman to remain in the fight for the entire engagement, taking down a battalion-sized armoured force and helping Task Force 269 armour to finish their mission of encircling Baghdad. Lieutenant Colonel J.R. Sanderson of Task Force 269 said of the A-10s, "The F-15s and the F-16s were good. The A-10s were absolutely fantastic. It is my favourite airplane. As long as that A-10 is flying above you and turning and moving, you can do anything you want to do." You could hear the roar of screams of joy when the air liaison officer would come over the radio and say, "I've got A-10s." The Warthog's cockpit is a perfect blend of pilot safety and modern technology. It has a single seat setup right in front of the wings, covered by a large bubble canopy that gives exceptional all-round visibility. As mentioned earlier, the pilot sits in a tough titanium armoured bathtub that weighs 1,200 pounds. It's built to take direct hits from 23mm cannon fire and indirect hits from 57mm shell fragments. The armour is made of titanium plates that are between 0.5 and 1.5 inches thick, with their thickness in each position determined by studies of where projectiles are most likely to come from. This armour makes up about 5% of the A-10's empty weight and is a lifesaver for pilots. Any part of the armour that faces the pilot is lined with multi-layer nylon shields to guard against shell fragments. The A-10C cockpit has seen some major upgrades when compared to the original A-10A. The precision engagement upgrade introduced glass cockpit displays, including 2 5.5-inch colour multifunction displays with moving maps. The hands-on throttle and stick configuration combine elements from the F-16's flight stick with the F-15's throttle design, giving intuitive control of the aircraft systems. It's also packed with modern avionics like multi-band communications, GPS and inertial navigation, Link 16 data link and satellite communications. The integrated flight and fire control computer handles weapon delivery calculations. The startup of the A-10 begins with setting the battery switch to power and the inverter switch to standby. This turns on essential electronics, allowing the pilot to check the health and state of the aircraft. Engine instruments are checked, the fire detection and bleed air leak detection systems are tested, gear and signal lights are turned on, fuel and oxygen quantities are checked. But the engines can't start with the battery. They need pressurized air, which is provided by the Auxiliary Power Unit, or APU. The APU switch is set to start. The pilot waits until the left fuel press light goes out, which confirms that the fuel pump is working. With the APU ready, it's time to start the engines, beginning with the left one. The engine comes to life, and as it does, the pilot keeps an eye on his gauges. Then the right engine is started. Once both engines are running, the APU is shut off. Further tests of the Warthog systems are done and the software is configured before the aircraft is cleared to taxi. While taxiing, the nose gear design means the A-10 turns tighter to the right than to the left. It's an oddity that pilots must bear in mind to avoid embarrassing mistakes. For takeoff, the flaps are extended, throttles are pushed to maximum, and brakes are released. The Warthog picks up speed. 1,000 feet into the acceleration, the pilot checks the engine RPM is at expected levels. If so, the takeoff continues. But 10 knots before reaching the takeoff speed, the pilot begins pulling slowly back on the stick, aiming for 10 degrees of pitch. As the aircraft accelerates, it lifts into the air. Once in the air, the pilot retracts the landing gear, but he maintains the same angle until the takeoff speed has been surpassed by 10 knots. Then the wing flaps can be retracted and the Warthog is free to fly. The Warthog is capable of making this process while operating from damaged runways, taxiways, or even highways if needed. This is due to the sturdy landing gear and low-pressure tires. The A-10C is designed for close air support rather than speed. It usually cruises at around 300 knots, which is relatively slow, but great for ground attacks. Pilots are better able to spot and engage small moving targets that faster planes might miss. With its large wings and low wing loading, the A-10 is highly maneuverable at low speeds and altitudes. It's able to pull up to 5.8 Gs during combat flight. It can operate effectively at 1,000 feet and in visibility as low as 1.5 miles, conditions that would ground most other military aircraft. Its loiter capability is legendary and is able to support ground forces by circling above a target at around 5,000 feet for up to 1 hour and 53 minutes. Combat radius depends upon the mission and payload, but usually ranges from 250 nautical miles or 288 miles, with a significant weapons load. Its fuel-efficient engines and large fuel tanks mean it can go on long missions, up to 800 miles, and with air-to-air refueling, the range can be extended almost indefinitely. The aircraft's approach speed is relatively low due to its large wing area and effective high-lift features. When initiating a landing, the pilot sets the flaps to 20 degrees and can deploy the split ailerons as air brakes to control descent rate and approach speed. The A-10's sturdy landing gear and low-pressure tires allow landings on rough, unprepared surfaces that would be impossible for conventional fighters. Even when landing gear is retracted, the main wheels still stick out, making emergency landings without the gear extended manageable and less damaging because the slightly exposed tires act as skids. An A-10 Thunderbolt II pilot named Colonel Harry Iceman Keeling had to land without nose gear. In order to do so, he maintained level flight at 160 knots before slowing down to just above stalling speed, around 120 knots, before flying the aircraft belly first onto the runway at a shallow angle. After the landing, maintenance crews simply jacked up the aircraft, performed some sheet metal repairs on the bottom, and remarkably, the aircraft was flying again just 1 week later. The A-10C Thunderbolt represents one of the most successful specialized military aircraft designs in aviation history. Born from the harsh lessons of Vietnam and the Cold War threat of massive Soviet tanks, the A-10 has proved its worth in every conflict since the Gulf War. Its mix of devastating firepower, exceptional survivability, and unmatched loiter capability has made it crucial for ground forces around the world. Whilst looking a bit awkward, the A-10 is very well engineered. Every detail from its tough titanium armor bathtub cockpit to its twin tails is focused upon keeping the plane airborne and effective. The huge GAU-8 cannon is unparalleled in its ability to take out armored vehicles, and the aircraft can carry a wide range of weapons. But unfortunately, all good things come to an end. Despite its incredible effectiveness, its slow speed makes it vulnerable in a potential war against opponents technologically similar to the United States. Therefore, the choice has been made to retire the A-10 in favor of the F-15EX Eagle II, another modernization of the F-15. The A-10C is a tough American tank killer, but if you're also curious about the MiG-21, the Soviet Union's devastating high-speed interceptor, please click on the link here. Thank you for watching. Breaking down such a complex machine for a film like this was a challenge. We've had to skip over some details, so if you notice any mistakes or have something to add, drop a comment below.